A bicycle safety organization claims that fatal bicycle accidents are uniformly distributed throughout the week. The table on the right shows the day of the week for which 775 randomly selected fatal bicycle accidents occurred. At alpha equals 0.01, can you reject the claim that the distribution is uniform? Complete parts A through D below. Alright, the first thing we need to do is go ahead and state the null hypothesis and the alternate. So we'll just go ahead and write down what these two hypotheses are. Remember that the null is always a statement of equality, and in this case the organization claims that fatal bicycle accidents are uniformly distributed through the week. So that's what our claim is, and that is going to be our null hypothesis. We want to determine if this is true, so we write the distribution of fatal bicycle accidents throughout the week is uniform, and the alternate hypothesis would be the distribution of fatal bicycle accidents throughout the week is not uniform. So in order to do this, we're going to first determine what our chi-square critical value is, and we're going to use that to determine what the rejection region would be. So this we're going to need to use the table, which in our textbook is table 6, but it's the chi-square distribution. And then we need to determine what our degrees of freedom are. So as stated above, alpha is 0.01, and for degrees of freedom, well, there are 7 days in the week, so we're going to use that to be what we subtract 1 from. So our degrees of freedom will be 6. So we need to go to our table for an alpha of 0.01 and degrees of freedom of 6. Alright, so here's a snapshot from the chi-square distribution. Remember that we are looking at degrees of freedom being 6 and a 0.01 significance level. Therefore, our statistic is going to be 16.812. This is a right-tailed test, so we know that our rejection region is going to be anything up here, and remember that chi-square in this case is 16.812, and our alpha is at 0.01. So now the next thing is to calculate the actual test statistic. So we want to calculate the test statistic, and in order to do that we need to know what our expected value is. So to do this we need observed and expected values. We already know what the observed values are because they're in the table. But now we need to determine what the expected value is. And to do that, we're going to need this list for comparison. But remember that there are 775 fatal bike accidents per week. So to find the expected, the expected value per day will be the sum of these numbers divided by 7. And when you add these up, you should expect to get the same number that we're talking about in the original problem, 775 accidents per week. So we take 775, we'll divide that by 7, and the answer will be 110.714. We'll just carry it out 3 decimal places. Alright, now that we've done that, we can go ahead and calculate the chi-square statistic. Now, we can go ahead and use the formula, and this is the formula for the chi-square statistic. And it's going to be the summation of the difference between the observed and the expected squared divided by the expected. But we're going to go ahead and use technology. We'll use StatCrunch to calculate this chi-square value. Alright, so copy the table into StatCrunch, and it'll look like this. And so, once you've copied the table in, we'll left-click Stat, and we will scroll down to Goodness of Fit, and hover over chi-square test, and left-click that. We're going to go ahead and select our second column, which is where the frequencies are. And expected, we could have a column of expected values, and we did just calculate those. But the nice thing about StatCrunch is it will do it for us. If we select all cells in equal proportion and simply left-click Compute, you'll notice that the expected values in this table are exactly what we had calculated. You'll also see that this is calculated your p-value, but the important thing to remember is that it's calculated your chi-square value, and in this particular instance the value is 2. So now that we know that chi-square from StatCrunch is 2, we can go ahead and finish the problem, because we need to decide, based off our initial assumption, whether we reject the null hypothesis or fail to reject the null hypothesis. Well, remember that since our chi-square value is 2, that's going to be somewhere way down here, and that falls fairly, I should say, squarely in the fail to reject. So therefore we will fail to reject the null hypothesis and conclude that at alpha equals 0.01 or 1% significance level, there is not enough evidence to reject the claim that the distribution of fatal bicycle accidents throughout the week is uniform. So as I said, we fail to reject the null hypothesis.